As we mentioned previously, the onCreate method is called when your activity starts executing. Now we have one activity in this particular example, so when the app starts executing, this activity will start executing, and this activity's onCreate method will then get called to build the GUI for the activity and to do any kind of custom configuration that's needed to help this app get up and running. Now, this one method is a method that you will override in every single activity that you create. And again, the reason for that is you need to be able to build the GUI as a minimum. But separately, you typically will have custom things you need to do for your app. And whatever you do in this method, you want to make sure you do it quickly. If this method takes any more than a couple of seconds to execute, then what's going to happen is a dialog will get displayed by the operating system called an ANR dialog, or application not responding dialog, and the user would then be given the opportunity to forcibly close your app. You never want ANR dialogs to get displayed on the screen if you can avoid it. Now, when you override any of the activity lifecycle methods in Android, you are required to call the base class version or the superclass version of the method, and that's what's going on here at line 38. This line was actually written into the overloaded onCreate method for us when we first created the app and the ADT plugin created the file tipcalculator.java. Now you'll notice that the call to onCreate and the overridden method itself receives a bundle called saved instance state. That bundle may be null if this is the very first time the onCreate method is being called to kind of launch the activity, or it may represent an actual object in which state information for our app was stored. And in the previous video, we talked about this issue of when the app configuration changes, for example, we want the current bill total and the current custom tip percentage to be saved so that they can be restored when the app comes back into the foreground. And that is what's going on with this bundle. That's where the information is actually getting stored. So the variable saved instance state, or the parameter saved instance state, will either be null if this is the first time onCreate is getting called and the app is just starting executing, or it will refer to an object that implements the interface bundle in the case where there's actual state information that needs to be restored because the app is coming back to the foreground. Now, we'll talk more about that bundle in a moment when we get down to this this if-else statement. At line 39 is a very important line of code. This is the line of code that's actually going to build the graphical user interface for the activity using the XML that was defined in our file main.xml. Now you remember in the XML file we describe what the GUI is going to look like, but that GUI description needs to be turned into an actual set of objects that represent the GUI and that are going to be displayed on the screen as part of the activity. And that process is what we call inflating the GUI, or inflating the XML layout. SetContentView is a method we inherit from class activity. You can see that it's an activity method by hovering over it here in the IDE. And it receives as its argument a constant that represents the name of the file in which the GUI is described. Now the R class is generated for you automatically by the ADT plugin tools, and you can see here that within our tip calculator project we have a gen folder that also contains our tip calculator package and a file in there called r.java. Now you're never going to modify this file directly, but I am going to open it here to show you what's included in the file. And you can see we have a final class called R, and within that final class we have a bunch of public static final classes called ATTR for attributes, drawable for constants that represent drawable items in your app. These would represent things like icons and images. In the class called ID, you see the names of all the different GUI controls that we described in the XML layout. So every single ID attribute that you create in the XML gets a corresponding public static final integer in the ID class, and we'll be using these names to look up the corresponding GUI components in our Java code so that we can get references to those components and then programmatically interact with those components. So this ID integer mechanism is an interesting way of implementing things because it loosely couples the actual GUI description with your Java source code and allows you to simply look up a GUI control when you need it, grab the corresponding reference at runtime, and then interact with that control. And we'll show you how to do that in a few moments. Also, down at the bottom here, we have a layout class in which you'll have a constant representing every single layout XML file that you provide in your layout folder or folders. And then finally, we have a string class in this as well, which represents the names of the string resources that we created. And those, again, were in the values folder in the strings.xml file. And by the way, if we were to create other types of resources like colors, then we'll wind up with a corresponding nested class here to represent those colors as well. And we can take a look at that in a subsequent app where we actually use color resources. So the reason I showed you this file is because we're using this main constant from the nested layout class inside of the class called R to help us specify which layout we would like to inflate as the GUI for this activity. So line 39 is going to perform that inflation, and it's all built in for you as part of class activity. Again, this was inherited from class activity. Now, in our app, depending on when this onCreate method is getting called, we're going to execute different portions of this highlighted if-else statement. Now, the saved instance state parameter is going to be null if your app is starting from scratch. So basically, if I am running this for the first time, or the app has been completely terminated and I'm now restarting the app from scratch, saved instance state will be null. And that's an indication to us that the current build total should be 0 and the custom tip percentage should be 18% because I'm just starting up the app from scratch. On the other hand, if I'm restoring this app and onCreate is being called, for example, just because the user rotated the device from portrait to landscape or from landscape to portrait, then I don't want to start from scratch. I want to display whatever the original bill total was that the user possibly already entered, and I want to display the custom tip percentage that the user previously selected. And in that case, I'm going to look up those values inside of this bundle object that's passed into the onCreate method for me automatically. And the way I do that is by calling various methods of the saved instance state object. In this case, the first one I'm calling is the getDouble method, and if you look at the description that pops up on the screen when I hover over it here, you can see that it's going to return the value associated with the given key. We can see it's going to return it as a double value, which happens to be the data type of my current bill total variable. And here you can see we're using the bill total constant name that we declared as a field back at line 18 in our code. So the bill total constant represents the string bill total, and inside of the saved instance state object, which is basically a hash table if you will, we have a string called bill total, which is the value of this constant, and associated with it is a corresponding value, which is in this case a double, so we're using getDouble to get it and return it and store it in current bill total. And just like with any Java API you might want to use, anytime you start looking at a new class or interface in Android, it's probably a good idea to take a detailed look at the class that the method belongs to or the interface that the method belongs to, and to take a look at the other methods that are available to you so you get a full sense of the capabilities. So for example, if I go click the link for bundle here, you can see that it brings me to documentation for the bundle class. I can also go to the website if I want, and notice the search developer docs field here. If I just type bundle, you can see it brings up anything that's got the word bundle in it. In this case, we're talking about the OS packages bundle type. And in the class called bundle, you can see the different constructors and methods that are available to you for that class. So let's go back over to our source code again. At lines 53 and 54, we're using the getInt method to get the custom tip percentage integer out of that underlying hash table data structure. Now, here at lines 58 through the end of the method, we start configuring the variables that will refer to various GUI controls in the application's GUI, as well as any of the event handlers that we're going to use to respond to various events. And the way we do that is with a method that we also inherit from class activity called findViewById. So you give this method an integer ID number from the auto-generated r.id class, and findByViewInId will look up that object that got inflated back at the beginning of this onCreate method and give it back to you as a view reference. So if you look at the code here, or the documentation here, you'll see that this method returns a view. Every single type of GUI control you can display on the screen is a subtype of view. And in order to process the GUI controls by their actual type and be able to interact with them properly, you have to cast them to the appropriate data type. So in this case, I know that tip 10 edit text is an edit text. Remember, I named my controls with their class name in them for a reason so that I could easily tell what they are. And I then cast the view that was returned to type edit text and store it in my tip 10 edit text variable. And I do the same thing for all the tip and total edit text. I also edit texts, excuse me. I also do this for the custom tip text view, for the tip custom edit text and the total custom edit text, as well as the bill edit text, which you see here at line 74. Now at line 77, I register for the bill edit text a text changed listener, and as I hover over that method, add text changed listener, you see that it requires as its argument a text watcher. Basically, every time the user types a new keystroke in the bill edit text, I want to respond to that keystroke with my bill edit text watcher, which is defined later in the code, and we'll take a look at that in a subsequent video. And I want to then update the calculations that show the tips and totals for the 10%, 15%, and 20% tips, as well as for the custom tip percentage as well. So this is registering the event handler that will respond to the text events of the user changing the text in the bill edit text object. And then finally, down here at lines 80 and 81, we get a reference to the seek bar because we want to also register an event handler that says when the user moves the thumb on the seek bar that we would like to update the custom tip and the custom tip total. So you can see here that we're setting for the custom seek bar an on seek bar change listener. If I hover over that method, you can see that it requires as its argument an on seek bar change listener object, and custom seek bar listener is an object that we've defined later in the code that will perform the events of updating the custom tip and total fields based on the seek bar changes.